Your development environment is the foundation of everything you build as an AI engineer. Get it wrong, and you will spend more time debugging dependency conflicts than writing actual code. Get it right, and every project starts cleanly, runs reliably, and scales professionally. In this first episode of AI Engineering, Zero to Master, we will build that foundation together, step by step, from scratch. Before we install a single tool, it is worth understanding why environment setup deserves serious attention. Most beginners skip this and pay the price later. When you install AI libraries carelessly, versions clash, packages overwrite each other, and projects that worked last week suddenly break. Every professional AI engineer works inside isolated, carefully configured environments. The habits you build today will save you enormous amounts of time across every project you work on throughout your career. Think of this episode as laying concrete before constructing a building. Everything else depends on it being solid. Python version choice matters more than most people realize. For AI and machine learning work in 2024, Python 3.11 is the correct choice. It delivers meaningful performance improvements over 3.9 and 3.10, and the major libraries, including PyTorch, TensorFlow, and scikit-learn, have thorough test coverage against it. Python 3.12 is available, but avoid it for now. Several important packages have not fully migrated, and you will encounter installation failures that are difficult to diagnose. Stick with 3.11 and you will have a smooth, stable experience from day one. On Windows, download the Python 3.11 installer directly from python.org. When the installer launches, there is one critical step. Tick the checkbox that reads Add Python to Path before you click Install Now. Missing this single step causes considerable frustration. After installation completes, open PowerShell and run Python version and pip version to confirm everything is working. If Windows launches the Microsoft Store instead of Python, navigate to Settings. Search for app execution aliases and disable the Python aliases there. That resolves the issue immediately. On macOS, use Homebrew rather than the python.org installer. Homebrew keeps your system tidy and integrates well with the rest of your toolchain. If you do not have Homebrew installed, the installation command is one line and takes only a few minutes. Then simply run brew install python 3.11. On Ubuntu or Debian Linux, the system Python is often outdated. Add the Deadsnakes PPA to your package sources, then install Python 3.11 along with the venv and dev packages. Those additional packages are essential for creating virtual environments and compiling certain AI libraries later in this series. Visual Studio Code is the industry standard editor for AI engineering work. It is free, fast, and supported by a vast ecosystem of extensions. After installing it, open the Extensions panel and install 6 tools straight away. The Python extension from Microsoft gives you IntelliSense and debugging. Pylance adds a fast language server that catches type errors before you run anything. The Jupyter extension lets you run notebooks directly inside VS Code without leaving your editor. GitLens surfaces Git history inline as you write code. Rainbow CSV color codes data files, and AutoDocString generates documentation templates automatically. Together, these extensions transform VS Code into a powerful AI engineering workspace. Installing extensions is only half the setup. You also need to tell VS Code which Python installation to use. Open the command palette using Ctrl+Shift+P on Windows and Linux, or CMD+Shift+P on macOS, and search for Python, select Interpreter. VS Code will display every Python version it can detect on your system. Select the one you just installed. This step becomes especially important once you start creating virtual environments, because each project will have its own isolated Python, and VS Code needs to know which one to use. Getting this right eliminates a large category of confusing import errors. Virtual environments are non-negotiable in professional AI engineering. The rule is simple: never install packages into your system Python. Always create a dedicated environment for each project. The built-in venv module is sufficient for most work. Run Python 3.11 mvenv to create the environment, then activate it using the appropriate command for your operating system. Once activated, your terminal prompt will show the environment name in brackets. Every package you install from that point onwards goes into that isolated environment and has no effect on anything else on your machine. This discipline prevents the version conflicts that derail AI projects at the worst possible moments. Conda offers capabilities that venv cannot match, particularly around GPU and CUDA library management. When you are working with deep learning frameworks that depend on specific CUDA versions, Conda handles those system-level dependencies far more reliably than pip alone. Install Mini Conda rather than the full Anaconda distribution. Anaconda bundles hundreds of packages you will never use and takes up unnecessary disk space. Mini Conda gives you the Conda tool itself and nothing more. Create your environment, specify Python 3.11 explicitly, activate it, and you are ready. Use Conda when your project involves GPU acceleration. Use venv for everything else. Jupyter notebooks are the lingua franca of AI research and data science. They combine code, visualizations, and narrative text in a single document, making them ideal for experiments you want to share or revisit. Install Jupyter Lab, which is the modern successor to the classic notebook interface. Critically, also install IPy-kernel and register your virtual environment as a kernel. Without this step, your notebooks will not see the libraries you installed in your environment. They will use system packages instead, leading to import errors and version mismatches. Once registered, your named kernel appears in Jupyter Lab whenever you create a new notebook. Always keep notebooks focused. One notebook, one question. Git is the professional standard for tracking changes in AI projects. Models evolve, experiments branch in unexpected directions, and datasets get updated. Without version control, recovering from mistakes or understanding what changed between runs is nearly impossible. Start by configuring your global Git settings, your name, your email address, and the default branch name. Set that branch name to main to align with modern conventions and GitHub defaults. Then, for every new project, initialize a repository immediately. Before writing a single line of code, create your .gtignore file. The order matters. You do not want to accidentally commit sensitive files or large binaries. A well-structured .gtignore file is one of the most important files in any AI project. Without it, you risk committing your entire virtual environment, which can be gigabytes in size, or accidentally pushing API keys stored in environment files. Your .gtignore should always exclude the PyCache directory, compiled Python files, Jupyter checkpoint folders, your virtual environment directory, any .env files, and model weight files with extensions like .pt, .pth, .h5, and .pkl. Also exclude your raw data directories. Raw data sets belong in object storage or a dedicated data versioning system, not in a Git repository. We will cover DVC for data versioning in a later episode. Once your local repository is initialized and your .gtignore is in place, connect it to GitHub. Create a new empty repository on github.com first, without initializing it with a README, since you already have local files. Copy the HTTPS URL and run git remote add origin, followed by that URL. Then rename your local branch to main and push. The AU flag on that first push sets the upstream tracking, so subsequent pushes simply require git push. GitHub now serves as your remote backup, your collaboration platform, and your project history. Every meaningful change you make should be committed and pushed regularly. If you have an NVIDIA GPU, configuring it correctly delivers dramatic speed improvements for deep learning work. Training times that take hours on a CPU can drop to minutes on a GPU. Start by installing the latest NVIDIA driver from nvidia.com/drivers. After installation, run NVIDIA SMIC in your terminal. If it displays your GPU name, driver version, and CUDA version, the driver is working correctly. For most AI engineering work, you do not need to install the full CUDA toolkit separately. PyTorch bundles its own CUDA runtime. Only install the toolkit independently if you plan to compile custom CUDA extensions. Mac OS users should note that CUDA does not apply to Apple hardware. PyTorch uses the Metal Performance Shaders backend instead. With your environment active, you are ready to install the core AI and data science stack. Run a single pip install command covering NumPy, Pandas, Matplotlib, scikit-learn, Jupyter Lab, and ipkernel. These libraries cover data manipulation, visualization, and classical machine learning. For PyTorch, always use the official installation command from pytorch.org rather than a plain pip install. The website generates the correct command for your operating system and CUDA version. If you are on CPU only for now, select that option and install. You can upgrade to a GPU-enabled build later. After installation, open Python and run import torch, followed by print torch version. To confirm everything is working correctly, you now have a professional AI engineering environment ready to build on. Python, VS Code, virtual environments, Jupyter, Git, and GPU support are all in place. In Episode 2, we move into Python fundamentals for AI, building the coding foundations that every engineer in this field needs. Subscribe to the channel, and we will see you next Saturday.